Hello, myself T. Kaushik Reddy from CSCB, and my roll number is 22971805770. And my topic for operating systems, the AAT Tech Talk topic is evolving an operating system for the web. So let's get started. So the introduction about OS, what exactly OS or the operating system does. So an operating system is an software program that serves as a conduct between computer or an interpreter between a computer hardware and the user. It's a piece of software that coordinates the execution of application program, software resources, uh, and a computer hardware. It also aids in the control of software and hardware resources such as file management, memory management, input output, and a variety of peripheral devices such as disk drive, printers, and so on. So every computer system must have at least one operating system to run other applications. Browser, MS Office, Notepad games, and other applications require an environment to execute and fulfill their functions. So what is evolution of an operating system? So operating systems have progressed from slow and expensive systems to today's technology, which has exponentially increased computing power at comparatively modest costs. So let's have a detailed look at the evolution of operating system. The operating systems can be classified into four generations that are as follows: first generation, second generation, third generation, and fourth generation. So the operating systems can be classified into four generations that are as follows: that are nothing but first generation, second generation, third generation, and the fourth generation. So next, background of operating system. So how does the operating system work? So let's know the background of the operating system. So, or the how it invented or how it is handled in, let's see, operating system was made in late 1950s to handle the tape storage. The General Motor Research Lab implemented the first OS or the operating system in 1950 for the IBM 701. Operating systems began to use disks in the 1950s. Unix OS was the first version that was developed in the late 1960s. Microsoft built the first operating system in the late 1960s. So, Unix OS was the first version that was developed in the 1960s. So, the Unix OS, nothing but the Unix operating system was the first version that was developed in the late 1960s. And the Microsoft has built the first operating system in the late 1960s. So the Microsoft has developed the first operating system, and it was called DOS. It was developed in 1981 by acquiring the 86 DOS company software from the Cetel company. Next, evolution of operating system. So how the operating system evoluted. So let's see the evolution of the operating system. So first, the serial processing. Next, the batch system. Next, the multi-programmed batch system. Next, the time sharing operating system, time shades, and the next Macintosh operating system. So this of the operating system is evaluated. The first is serial processing, then the batch system, then the multi-programmed batch system, then the time shared by operating system. Next, the Macintosh or the Macintosh operating system. So how? First generation. In first generation, it was serial processing. The evolution of operating system began with serial processing. It marks the start of the development of electronic computing systems as alternatives to mechanical computers. Because of the flaws in mechanical computing devices, human calculation speed is limited, and they are prone to making mistakes. Because there is no operating system in this generation, the computer system is given instructions that must be carried out immediately. Next, programmers was incorporated into hardware components without an operating system by 1940s and 1950s. The challenges here are scheduling and set up the user logs in for machine time by wasting computational time. Setup time is required when loading the compiler, saving the compiled program, the source program, linking, and buffering. The process is restarted if an intermediate error happens. Example, Windows 95 and 98 are examples of serial processing operating systems. Next, the second generation, batch system. The batch systems marked the second generation in the evolution of operating systems. In the second generation, the batch processing system was implemented, which allows a job or task to be done in a series and then completed sequentially. The computer system in the generation doesn't have an operating system, although various operating systems functionalities are available, such as FMS and IPSOS. It is used to improve computer utilization application. On cards and tapes, jobs were scheduled and submitted. Then, using job control language, they were successively executed on monitors. The first computers employed in the batch operating method created a computer batch of jobs that never paused or stopped. Sorry, the software is written on punch cards and then transferred to the first the software is written on the punch cards and then transferred to the tapes processing unit. When the computer finishes one job, it immediately moves to the next item or the tape on the tape. Despite the fact that is inconvenient for the users, it is designed to keep the pricey computer as busy as possible by running a leveraged stream of operations. Memory protections prevents the memory space that makes up the monitor from being changed, and the time prevents the job from monopolizing the system. When the input and output devices are in use, when the input and output devices are in the use, the processor remain idle due to poor CPU utilization. Example, MBS operating system of IBM is an example of batch system, processing operating system. Third generation, multi-programmed batch system. The evolution of operating system impacts the third generation with multi-programmed batch system. In the third generation, the operating system was designed to serve numerous users simultaneously. Interactive users can communicate with the computer via an online terminal, making the operating system multi-user and multi-programming. It is used to execute several jobs that should be kept in the main memory. The processor determines which program to run through job scheduling algorithms. Example, Windows and iOS are examples of multi-programmed batch operating system. First generation, second generation, and the third generation. The first generation is analog for everything, analog video matrix switch, next the monitor, then the control panel, then the recording VCR, then the storage tapes. Second generation, analog switching the digital recording, fiber, mutus, monitor, analog video matrix switch, control panel, storage disk, recording DVR. Third generation, analog switching, IP recording, fiber, mutex or the mutex, monitor, analog video matrix switch, control panel, encoder, and the storage and the NVR. In the third generation, so in each generation we have some improvement in the OS. The fourth generation, the operating system is employed in the age for computer networks, where users are aware of existence of computers connected to one another. The era of network computing has already begun, and users are comforted by graphical user interface, GUI, is nothing but the graphical user interface, which is incredibly comfortable graphical computer interface. In the fourth generation, the time-sharing operating system and the Macintosh or the Macintosh operating systems came into the existence. Time-sharing operating system. The time-sharing of an operating systems had a great impact on the evolution of the operating system. Multiple users can access the system via terminals at the same time, and the same processor time is divided among them. Printing ports were required for programs having command line using interface, which required written responses to prompts or written commands. The interaction is scrolled down like a roll of paper. It was previously used to develop batch replacement systems. The user interface directly with the computer via printing ports, much like electric teletype. Few users shared the computer immediately, and each activity was completed in a fraction of a second before moving on to the next. By establishing iterations when they are receiving full attention, the fast server may act on a larger number of users and processes at once. Multiple programs use time sharing systems to apply to the computer system by sharing the system interactively. Example, Unix operating system is an example of a time sharing OS. So Unix operating system is an example for the time sharing or time sharing operating system. Next, Macintosh operating system or the Macintosh. It was based on decades of research into graphical operating systems and applications for personal computers. The photo depicts a Sutherland pioneer program Sketchpad that was developed in 1960, employing many of characteristics of today's graphical user interface GUI, but many of the characteristics of today's graphical user interface. But the hardware components cost millions of dollars and took up a room. The initiative on massive computers and hardware improvements made the Macintosh commercially and economically viable after many research gaps. Many research laboratories are still working on research prototypes like Sketchpads. It served as a foundation for anticipated products. Example, Mac OS 10.6.8, Leopard, and OS X 10.7.5, Lion are some examples of Macintosh OS. Next, features of operating system. Information and resource protection. So these are the following are the features of the operating systems or the OS. The first one is the information and resource protection. Next one is protected and supervisor mode, handling IO expectation operations, program execution, memory management, virtual memory, multitasking, error detecting and handling, manipulation of the file system, allowed disk access and file system devices, drivers, networking security. Advantages of OS, a user-friendly interface and source of computing. So let's brief explanation advantage of the user-friendly interface. When the Windows operating system was first released, it also included GUI, that is graphical user interface, which made using computers far more natural than the previous command line interface. Furthermore, users can swiftly interact with, and communicate with the computers. Source of computing. The operating system is a software program that connects the user to the hardware. It enables users to enter data, process it, and view the results. Users can also interface with computers via the operating system to conduct various operations such as arithmetic calculations and other essential tasks. Sharing resources. Printers, modems, players, and fax machines are also used by an operating system to share data and import important information with other users. Furthermore, a single user can send emails to several users at the same time. To share the same info using an operating system, you can also transfer applications, photos, media items from your PC and other devices. Data protection. On the computer, there is a lot of user data that can only be accessed with the help of an operating system. Apart from storing and accessing data, an OS other crucial role is to handle data safely and securely. Windows Defender, for example, finds and eliminates dangerous and harmful files in the Microsoft Windows. It also protects your information by encrypting it bit by bit. And involvement of coding lines. Operating systems now allow users to access hardware without writing programs thanks to GUI. Users do not need to write the lines of code to access the hardware capability of computer system as they did previously. Multitasking. An operating system can manage multiple tasks at once. It enables users to complete multiple things at the same time. Next, update software. The operating system is a piece of software that needs to be updated on a regular basis in order to keep up the rapidly changing the features. OS must increase benchmarks and handle all aspects of computer operating as our other programs and software receive upgrades to improve their usefulness. An operating system can be updated without difficulty. And I want to tell brief information about evolving an operating system for the web. So evolving an operating system for the web involves creating the OS that's tightly integrated with the web technologies, allowing seamless online functionality. Next, and cloud-based services. It often emphasizes lightweight design, security, and compatibility with web applications. Examples include Chrome OS and some adaptations of Linux distributions tailored for web-centric usage, etc. And more information about the same topic, like is creating an information OS tailored for the web involves several key considerations, like integrated with web technologies. That is, the OS should seamlessly integrate with web browsers, web applications, cloud and cloud services. This means providing robust support for the web standards like HTML, CSS, and JavaScript. Cloud-based services. A web-centric OS often relies heavily on cloud-based services for storage, processing, and collaboration. This requires robust networking capabilities and tight integration with popular cloud platforms. Next, security. Security is a paramount in a web-focused OS due to the inherent risks associated with the online connectivity. Strong security measures such as sandboxing, applications, encryption, and regular updates. These are essential to protect users' data and privacy. Next, compatibility. Ensuring compatibility with a wide range of web applications and services is crucial. This may be involving optimizing performances, providing support for the popular web frameworks or the etc., and ensuring consistent rendering across the different builders. User experience. User experience is a key in any OS design. A web-centric OS should provide an intellectual interface, smooth performance, and seamless integration in the web services to enhance user productivity and satisfaction. Device agnosticism. To cater to a diverse range of devices, including laptops, tablets, and smartphones, the OS should be designed in such a way that to be device agnostic. This means supporting various form factors, screen sizes, input methods, and hardware configurations. Examples of web-centric operation systems include Chrome OS, developed by Google. Chrome OS is based on the Linux kernel and uses the Chrome web browser as its primary user interface. It emphasizes the web applications and cloud services with tight integration with Google's ecosystem. Next, Cloud Ready or Jolly Cloud and Resta. So these are the OS continue to evolve, incorporation new features, improving the performances and adapting to the changing landscape of the web technologies and user interface. So the examples for the web-centric operating systems are Chrome OS, Cloud Ready and Jolly Ready. So Cloud Ready is nothing but Cloud Ready is an operating system based on Chromium OS, the open source counterpart of Chrome OS. Uh, it isn't run as it is designed to run an old hardware, enabling users to repurpose aging laptops and desktops as web-centric machines. Next, Jolly Cloud. Jolly Cloud, known as the Jolly OS, was an early example of web-centric OS that focused on cloud services and web applications. It aimed to provide an undefined interface for accessing, managing online resources. So, the brief information about the evolving and operation system for the web is nothing but the evolving and operating system for the web involves creating OS that's tightly integrated with web technologies, allowing seamless other functionality, online functionality, and cloud-based services. It often emphasizes the lightweight design, security, and compatibility with web applications. Examples include Chrome OS and some adaptations of Linux. So this is my talk. This is so yeah. Thank you. This is my tech talk or the tech talk topic for the operating system. The topic name is evolving and operating systems for the web. So yeah, thank you.